I'm not usually a fan of questions on the trapezium rule because I prefer answers to my integrals exact. However, this is quite a nice relationship between the trapezium rule and a substitution question. So in this question, in part A, we're asked to use the trapezium rule with two strips to show that this integral here is approximately 11/4 minus root 2. The trapezium rule I've got written down here. If you haven't seen this before, it can be quite daunting. What's y0? What's yn? What's h? What's b? What's a? What's n? There's so many letters. What we're trying to do is, if you imagine the graph somewhat like this, you are making trapezia, should I say, of equal strips like this. So not curved but completely flat. And you are adding together the areas of them. So y0 means, well, take the first value here, which I call x0, and find the corresponding y value, y0. x1 will be next, and y1 will be the next y value. Then x2 with y2 corresponding, and then you might have a few more strips. xn is the last one. yn is the last y value. In our case, we're only given two strips, which is not very many for a question like this, but that tells us straight away that n is equal to 2. And using the formula, we can see the limits of the integral are 0 and 4. So that means a is 0 and b is 4. That means also that x0 is 0 and xn is 4. This tells us, using the formula for h, that this is, that should be over n, b minus a over n, which is 4/2, which is 2. This also tells us the value of x1 being 2. In our case, there's only two strips, so we can basically ignore this last one. x2 is the same as xn. So what about the corresponding y values then? What's the y value when x is equal to 0? Well, essentially it's saying sub in the value of x at 0. So 1/2 plus 0, 1/2. What's y1? That's saying evaluate the value of y when x1 is here, so 2. So 1/2 plus root 2. And then finally, what's y2? y2 corresponds to x2. 1/2 plus the square root of 4. Square root of 4 is 2. 1/2 plus 2 is 1/4. Now we can get cracking with the formula. So the integral from 0 to 4 of 1/2 plus root x dx is going to be, according to the formula, 1/2 times by h, which is 2, times by, nice big bracket, y0, which is 1/2, plus yn, the last value. It might be 3, it might be 4, it might be 5, doesn't matter. It's the last value, plus 2 lots of all the values in the middle. And I say all because there's usually more than one. In this case, there's just the one in the middle. So 1 lot of the first value, 1 lot of the second value, and 2 lots of the middle value or values. 1/2 times 2 is 1. 1/2 plus 1/4 is 3/4. And then I'm going to add 2 lots of, I'm just going to rationalize the denominator here, like this. 2 lots of this, 4 minus 2, that's equal to 2, cancels with the 2, 3/4, I really should do an equals here, 3/4 plus 2 minus root 2, which is equal to, add 2, adding 8/4, so 11/4 minus root 2. So therefore, the integral is close to this, which is what the question wanted for 5 marks. Not bad. Okay, part B, we're doing a substitution. Now we're on to the real stuff. We get to find the actual value of this. 2 plus root x dx. The substitution is x equals u squared. What do you do with the substitution? Well, you need to change everything x into u. You need to change dx as well. The only way to do that is to take the derivative here, like this. And this is essentially a fraction. You can treat it as such. Dx is equal to 2u du. Moreover, this is root x, which is the same as u if we take the square root. So I've replaced the root x with a u, and I've replaced the dx with a 2u du. I'm also going to do the limits. When x equals 0, that means that 0 is u squared. So u is 0, and when x is 4, 4 is equal to u squared, so u is 2. I'm taking the positive value here, could take the negative one, I should get the same answer. So new limits are 0 and 2. I'm going to take the 2 out, because it might make it a tiny bit nicer. And in this one, I'm going to do a bit of a trick. So there are other ways to do this. You could do another substitution, but I'm going to do a little trick here. I'm going to add 2 and then subtract 2. It's the old trick of adding nothing. The reason I'm going to do that is because now if I separate this out, 2 plus u over 2 plus u minus 2 over 2 plus u. Well, this is just 1. And this integral is much nicer. So this integral is going to be, what's the integral of 1? Not x, but u, because this is all with respect to u. And this is minus 2 lots of ln 2 plus u, like this. The reason it's ln is because the derivative of the denominator is 1, and that's 2 lots of 1 here. That's what this 2 could represent. So it's 2 lots of ln 2 plus u. So sub in the top limit, 2 minus 2 ln 4 minus, sub in the bottom limit, 0 minus 2 ln 2, which is 2 minus 2 ln 4 plus 2 ln 2. 2 minus 2 ln 4 plus ln 4, use your log rules, move that 2 up. 2 minus ln 4 minus 2 plus 1 is just minus 1, which is equal to 4 minus 2 ln 4. Doesn't look like it answers in any specific way, just an exact answer, so that's all good. If we now look at part 3, now we get to make the connection between ln2 and the root 2. So the two integrals should be the same because they're the same integral. So that means that this 11 over 4 minus root 2 should be equivalent to the answer of the integral. So 4 minus 2 ln 4. The answer wants ln 2, so we need to turn this back into ln 2. So this means that 11 over 4 minus root 2 is similar to 4 minus 4 ln 2. If I make this ln 2 squared, bring down the 2 to make that 2 into a 4. If I subtract 4 from both sides, it's the same as subtracting 16 quarters. So this should be minus 5 over 4 minus root 2, like this. And if I divide everything by minus 1, then we get this. Which implies, finally, if we divide by 4, I've already divided, but I didn't mean to divide by 4. I was getting ahead of myself. 5 over 16 plus root 2 over 4. So it turns out that k is equal to, if you want to write that down, you don't need to, k is equal to 5 over 16. Well, there you have it. I hope you enjoyed that question as much as I did. Here are 2 more to have a go at.